So we're still continuing our discussion on optical properties of matter, right? And in the last lesson, we spoke a little bit about the photoelectric effect. In this session, in this lesson, we're going to focus on absorption as well as something we call emission spectra or absorption or spectrums. It doesn't matter. Okay, so there's the way electrons surrounding an atomic nucleus are arranged. They are arranged in series of levels around a nucleus, and so let's say this is our nucleus of a certain atom, right? And then we can draw energy levels around that nucleus. Of course, I'm terrible at drawing, right? And then we can say this is energy level number 1, energy level number 2, and then this is energy level number 3. So they are organized in order of increasing energy from there, from right. But then another way that we can actually draw this thing is that we can just say, okay, so if we have we can draw something called an energy level diagram, where we have our energy on this side, and then we have energy level number 1, energy level number 2, energy level number 3. I'm sorry for that. So we have energy level number 3, and now this energy level number 1, we call it the ground state, and these are organized in terms of increasing energy. So the energy is increasing from energy level number 1 to whatever it can go up to infinity, right? And electrons are organized in these energy levels. So something interesting happens in a setup where I'm gonna draw it quickly. In a setup where we have perhaps an electron. So let's say draw this is, maybe I call this my final energy level EF, and then let me call this my initial energy level E1, EI actually. So let's say we had an electron, and this electron transitioned, so it moved from a higher energy state or higher energy level to a lower energy state or lower energy level. So it was in this upper energy level and it transitioned down, and during that process what we notice is that it actually will release a photon of energy. And this photon of energy, the value of this photon of energy will be equals to the separation between these two. So the value of this E photon will be equals to the difference between EF and EI. So the separation, that will be the value of that photon that will be emitted. So an electron is moving from a higher energy state to a lower energy state, and as a result, a photon equal to the separation here, or the change in energy, will be released. So that change in energy is given by nothing but EF minus EI, right? So that's something that is interesting to know. But now we already mentioned that energy can be related to frequency in this form, where we say E is equals to HF, and then we know can write, simplify this further and say where F is equals to C over lambda, right? So that specific photon that is released, or wavelength, will have a wavelength or a frequency. It will give out a specific color. So what do I mean? Let's make an example. I'm gonna remove this quickly. So let's say we had energy level 1. I don't need to write E1. So we had energy level 1, 2, 3, and we had 2 cases. So 1, 2, 3, quickly. So we had those energy, and then we had an electron here that was transitioning from energy level number 3 to energy level number 1. So the transition was from E3 to E1, and then during that process we said it will give out a photon of energy with a energy equal to the difference in energy between these two energy levels, right? Cool. And then we had another photon here, another electron that was transitioning from energy level number 2 to energy level number 1. So it's moving from E3 to, E2 to E1. And that will also give a characteristic photon of energy out. And then the value of that energy will be equals to the separation or the difference between these two energy levels. So we can already see that the wavelength of this will be different from the wavelength of this. So, and this wavelength will correspond to a certain color. So let's say for this instance, the color was blue. I'm just being random right now. And then for this one, maybe the color is like red. So it will actually release that photon of energy, which will emit a different color. But now we've spoken about emission, where an electron moves from a higher energy state to a lower energy state. As a result, there's an emission of a photon with a wavelength, and then the energy of that is just the difference between the two energy levels involved, right? But then atoms do not only emit photons, they can also absorb them. So what do I mean? So we can have a sort of a reverse situation where we have, let's say this is the final energy level and this is my initial energy level, and then we have incoming light or photons of energy that are coming. So they have an energy of about E photon, right? And they coming, and then we have an electron here. This electron will actually be excited if this energy equals to the difference between these two energy levels, right? This electron will actually be excited. It will move from a lower energy state to a higher energy state, and in that respect, what we see that a photon was absorbed by our atom, making this electron excited from a lower energy state to a higher energy state. So in terms of what is it that you're supposed to know, especially at grade 12 level right now, is that we actually just supposed to know what is the difference between an absorption as well as an emission spectra, and how we can define that. We can say that an absorption spectrum is formed when a certain frequencies of electromagnetic radiation passing through a system are absorbed. So it's the matter of that absorption, and then we will have that electron being excited from one energy level, a lower energy level, to a higher energy level, and then as a result we can form a sort of an absorption spectrum. And then in reverse, an emission spectra, we have an electron. Okay, this is F here. An electron from a higher energy level transitioning, I don't know why I wrote it. I'm doing this. Transitioning from a higher energy level to a lower energy level, and as a result it releases a photon. So that emission spectrum is formed when those certain frequencies. So remember, energy is related to wavelength, is also related to frequency. So that's why I keep mentioning frequencies. So those frequencies of electromagnetic radiation are emitted due to an atom making a transition from a higher energy level to a lower energy state, right? So that's a few of the things that you are supposed to know, at least at this level. I don't want to get too deep into it and speak about things that are really not necessary, that you might actually not be tested upon. So this actually brings us to the end of this lesson. In the next lesson, we're actually going to be doing a calculation. It's a question from a previous question paper about the photoelectric effect.